All right, how's it going, everybody? So today we're going to be continuing the fourth course boss mod that we've been making. If you haven't seen the previous video, I highly recommend checking out that one first because today's video is going to be a continuation of that tutorial. So if you haven't seen that, again, definitely check that one out first. So today what we're going to be doing is working on adding new behaviors. If you remember from the last video, we mainly worked on tweaking existing behaviors, making attacks faster, tweaking probabilities, things like this. But now what we're going to do is we're going to add new behaviors to the boss. And so this was spurred on by some playtesting that I did on the original version that we had in the mod. And so you can see here, what we did in the previous version was we made it so that the fourth course boss always used aim slam and targeted the player's location. However, the downside of this, if you see, we can obviously, um, find ourselves quickly in a dire situation because it is constantly slamming the ground, which is what we want. However, because it always slams our position, we can do something like this instead. And as you can see, basically permanently lock the boss into a certain position, which isn't really what we want, right? And not only that, but if we are to get above the boss like this, well, we can just continually bounce on his head and trivialize the entire phase, which also isn't what we want, obviously. And so there's a lot of different ways that we can approach fixing this, and this is also why playtesting, your boss concepts or whatever is important, because we need to fix that, but we want to do it in an engaging way, right? So what we're going to do here is we're going to add a new behavior to the fourth course boss so that instead of just being a punching bag, basically, it's going to dodge out of the way to the left or right and reposition itself so that it's not in as much trouble when the player tries to do something like that. So that's going to be our goal for today. We'll see how well this goes for us. So let's start off by coming back to our finite state machine for the fourth course boss. If you guys remember in the last video, we were taking a look at the P1 state, and we were manipulating the set float value and the send random event v4 actions within it. Now, that was great for changing the behavior that already existed, but now we're going to try to add a new state to this particular finite state machine and then wire it into the existing logic that is present here. So how are we going to do this? Well, first, let's figure out what it is that we want to do. What we're going to do, as we said before, is we're going to create a reposition state, which is going to be executed to allow the boss to dodge out of the way after it attacks, so it's not basically a sitting punching bag. So how are we actually going to go about doing that? Well, the first thing that we need to do is we need to figure out what can we repurpose from this existing finite state machine so that we don't have to do absolutely everything from scratch. We will still need to do some things from scratch, and I'm going to show you guys, how to do that as well. But, let's not reinvent the wheel here. We're going to start by trying to see what parts of this we can already just repurpose and not have to, redo all of that work that already is here for us. So if we're going to have the boss slide to a certain position, there's already an attack that does just that. If you think about the swipe animation, when the fourth chorus is going to swipe from one side or the other, it jumps to the side that it's going to begin the swipe at, and then it ends up swiping, and then it moves to the other side. So in the beginning of the swipe L, you can see there is a action called animate position 2. And animate position 2 is exactly what we're going to need here, because this will set the fourth chorus position to this value called toValue, which in this particular case is this set of parameters here, and then it will do it over some time duration. Like, it doesn't just teleport it to that location, it slides over. And so that's going to be pretty nice, and this is what we're going to be looking for here. Now, we can take this particular action, and then we can create a new copy of this action in our state, and that will execute and allow us to move the fourth chorus to any position that we want within our new repositioned state. So let's not do too much at once. Let's just try to do that by itself, and then we'll go from there. All right, so we're back to our code here, and this is what we had in our last tutorial that we were looking at. And so we're going to start off just with a little bit of cleanup. We're going to move all the logic that we had for our patching of phase 1 to its own method. That way we don't have to get a little bit too messy with it. So we're just going to say public static void patch phase 1, and then we are going to make a FSM the parameter, and then we'll just change this to say FSM, and then we don't need this. And then now we can just say patch phase 1, and we'll pass in the instance.fsm. Okay, so again, that's just a kind of cleanliness change. We're not doing anything logical there. And now we're going to create another method, and we're going to call this one create reposition phase. And this will also take in the FSM. And so we'll do this and create reposition phase. And now we're good to go. All right, so let's start off by just trying to create the new state for our reposition logic. So we will have a var, and we'll call this reposition state. And we're going to set this equal to a new FSM state. And then we're going to pass in the FSM that we have got from the original instance that we have obtained. So optionally, you can give it a name. I do recommend doing that though, because it will make it easier to find when you're doing other calls later on. So we'll call it reposition. And now we need to add it to our current list of states. So all we've done right now is make the object, but we need to add it to the FSM itself. So the way we do that is we say fsm.states is equal to fsm.states.append, and then we will add the reposition state, and then we'll say to array. So this will take the reposition state that we just created, and it will add it to the list of states that are available on that particular finite state machine. So now what we've done, if we go back to our FSM viewer, is we've essentially created an empty box. So you can imagine there's a box like right here or something. There's no transition points leading out of it yet. There's no actions inside of it. There's just an empty box here called reposition that doesn't do anything. So the first thing that we want to do is we want to make it do something, right? So let's add some actions to our reposition state so that it can actually move the boss like we want to. All right, so in order to do this, we're going to need to animate the fourth chorus with that animate position 2 action that we saw on the swipe state. So we're going to create that action. We'll call this the animate 2, and this is going to be, well, let's call it animate 2 action just to be a little bit more specific. And then this is going to be a new animate position 2. And this is a good time to bring up the fact that the actions that exist here, each one of these actions is its own class within the code. So if you type any of these, so if I hit F12, or you can right click on the particular class and click go to definition, if you do this, you'll see this is the logic that's executed whenever the particular action that you're calling is called in the finite state machine. And so this will help you to debug what's going on in a lot of situations, because you can see, oh, okay, this is how this particular action actually executes its behavior, and then maybe you can make some kind of tweaks or something depending on what exactly is happening there. So in this particular case, since we are modeling this after the swipe L, we can kind of just copy a lot of the information here down the list, and then we will be able to basically emulate the position that happens here. So I'm going to just move this over to my other monitor so that I can see it, but you can just copy obviously from my screen here. So we want to do set a game object. So this is just the game object that is being moved by the boss, or by the action, sorry. So it's going to be use owner. So this is saying that the object that's going to move is going to be the owner of the finite state machine, which is the fourth chorus boss. So then we can just go to value, and this is going to be equal to a new FSM vector 3. So this is just a end position. So we're going to put the value for this is equal to a new vector 3. And then here we can specify the 3 values. Now I've already looked this up based on some other actions that exist within the boss. So this is going to be the position that we want here. And then if you're curious how I got that information, I was looking at the slam positions for the fourth chorus boss, and I was seeing, like, based on these values here, where it moves for each individual slam. And then I decided on some values based on just the things that I saw here. So next up, we have local space is equal to false. Local space is basically, in Unity, there's a concept of a world space and a local space. You always want the world space, so in this case, that means that we need to set local space to false. Then time, that's how long it's going to take to get to the location. So we'll just say a new FSM float, we'll say it moves there in about a quarter second. Then speed, this will be also a FSM float. That's how long it will take to travel there. Then we need a delay. We don't actually need to set a delay, so we can just say new FSM float 0f. Then ease type. So ease type is basically what amount of like speed up or slow down acceleration that's happening. So there's a lot of different options here that you can go for. The one that Team Cherry already uses for the particular boss that we're doing is actually not this one. It is ease. It is ease out sign. This is one. Ease out sign. But you can kind of play around with them, see which one you like. There's a lot of different options that are interesting. Reverse is just going to be false. That just means moving backwards, which we don't want here. And real time is also false. Okay, and now what we want is we're going to create another action as well. Now, currently, we just have this enemy position 2 action, but we don't want it to immediately slide over to a position and then immediately slam back over to the player position with another attack. We're going to give it a slight little wait as well. So for that wait action, we're just going to make another action here. So we'll say var wait action, and this is going to be equal to a new wait. And here we're just going to specify a amount of time. So we can say time is equal to, how long we want to do? New FSM float, let's say 0.5 seconds. So now that we have this wait action, we can go to our reposition state, and then we can go to our actions list. And now we can set this equal to a new FSM state action, FSM state action array. And then now we can add the 2 actions that we've just created. So the animate 2 action and the wait action. And so now this has now created our state. So our state now exists. Again, if we come back to our finite state machine here, it exists as a box, but the box still doesn't have any arrows pointing to a new state, but it does have the required actions on the side here to actually perform this slide correctly if it were to enter that state. So now let's talk a little bit about the transition between states in the finite state machine. Now the way that this works is, as we've talked about before, there are the states, and then on this right panel here, there are the actions that exist within the state. Now, if we look at these other tabs here, we can see there's an event tab and there's a variables tab. But specifically with this event tab basically lists all of the different events that are present in this finite state machine. So this is not unique to any given state. This is all of the possible events that are shared between any of the particular actions or states within this finite state machine. And so the way that we can look at this is if we see in this case here, all of these different states have actions that in some way fire an event that allows it to dictate that it is done with a particular state and it should go to a new one. So for example, we can see in this idle state, there is a finish event here, and the finish event is the event called finished. And so this corresponds with this finished event right here. And we can see if we follow the arrow, and you can see, you notice how there's 2 arrows that are coming out of idle. There's this one here, and then there's this one here. So the one that is kind of in line with the actual text finished, that is the one that is corresponding to that event. So we can see that finished goes to phase check. So when that particular state is over, then it transitions to phase check. So the way that you can think about this is the state has an event. When the event is fired, there is a transition that transpires that will move from the current state to whatever state is decided to be pointed to by that particular transition. And that's what we're going to be doing in our particular case. Now, to help drive this point home, I came up with a brilliantly drawn paint image to kind of explain the point a little bit better. Let me see if I can get both these on the screen at the same time here. But basically, this little section here is how it exists right now, right? So the idle state has a transition, and that transition is activated by the firing of the finished event. When that event is fired, then the boss will transition from the idle state to the phase check state. Then in the phase check state, it'll go through the phase check logic, and then there will be another event that fires. And in the case of phase check, there's 4 different events that could fire. So if we look here, you can see it says int switch, and then it's checking whatever phase that it's in between 1 and 4. And then you can see here it has send event. So it's sending one of these 4 events depending on, what phase the boss is currently on. And then that will trigger that event, which will then transition to whatever corresponding phase the boss is on. So currently what we have is we have this floating reposition state that's just, out in the ether. And so what we need to do is we need to give it a transition, and we want to drag on that transition. And then we want to move it so that it's between the idle state and the phase check state, so that it will basically, get weaved into the existing logic of the finite state machine. So let's start off here by creating the event that's going to trigger the transition from our current state to the phase check state. So we're just going to say var finished state, and this is going to be equal to the FSM event dot finished. Now this is a very particular event that has pretty common use. As you can see here, most transitions fire because of a finished event. You can create a new event if you want, and that is useful if you have a phase that, or not a phase, but a state that transitions into multiple different states depending on some condition. So something like aim slam, right? Instead of just having a finish, they have different states that it goes to depending on some situation. But in our case, we can just use the finished event here. So now we just can simply add finished event is equal to our finished event, or finished state. Oh, wait, I called this state. Oops. Let's call this finished event to have proper naming here. But finished event is going to be our finish event. Now, every single different action can take a finish event. So for example, we could have had finish event over here, right? We can define it wherever we want. The point, though, is just that we have one action, at least, in our state that has a event that fires that allows us to transition out of it. Otherwise, we'll get trapped in the state forever, and then the boss will just hang there, which is obviously not what we want. So now that we've created this, what do we actually do to transition out of that particular phase? Well, what we need to do is we need to wire up those transitions. So as we said before, let's go back to our paint drawing here. We have this reposition, and we want to move the repositioned state into the middle of idle and phase check, and we want to give it that arrow. So let's start off by giving it the arrow to phase check. The first thing that we need to do is we're going to need those 2 states that we're going to be wiring between. So we'll say fsm.getState, and we will call this the idle, or not call it by idle, but we'll get the idle, and we'll do phase check, and this is going to be fsm.getState phase check. And again, we could be null safe and go through that whole process. We're not going to do it this time, but you definitely should be doing that, especially if you're working with states that you're creating yourself. It'll save you a lot of problems if you do go through the null checks for all of these kind of things. But let's go and do a new transition. So we're going to first create the transition from the current repositioned state to phase check. So what we're going to do first, going back to here, is we are going to make it so that reposition points to phase check. That's what we're going to do first. So how are we going to do this? We're going to say, we'll call this repo to phase check. And this is going to be equal to a new transition, FSM transition. And then it's going to be FSM event. So this is going to be what event fires to create this transition. And so that's going to be, of course, our finished event that we defined earlier. Then the next question is, okay, now what state are we going to go to when this event is fired? So this is going to be the phase check dot name. So that's the name of the event or name of the state that we're going to go to. And then here for toFSM state, that's just the phase check itself. So when we create this new transition, we define what event fires to move it to this particular state, then what is the name of the state, and then what is the actual state itself. Okay, so now we need to add this new transition to the transitions on our reposition state. So we're going to say reposition state dot transitions, And we're going to set this equal to a new array of transitions, and this is going to be equal to our reposition repo to face check state. So what we're saying here is we're creating a new array of transitions, and we're just going to have the one for now. But this has now created the link between our reposition state and the phase check state. So if we come back to our paint drawing here, what we've done now is we've made it so that phase check is pointed to by reposition. However, it's not that simple because idle also still points to phase check, and we did not break that connection. So currently, it kind of looks more like this. It looks like idle and reposition both pointing to phase check. But the thing is, we don't have anything that points to reposition. There is something that points to idle, right? There is some other state that happens before idle that comes and transitions into idle, but there's nothing that points to reposition as of now, which means that currently, while the reposition state, if it were to ever be entered, would work normally and go into phase check, we are not entering reposition. So the next thing that we need to do is we need to make it so that reposition is entered from idle, and that would create the full transition that we want of having phase check at the end, reposition in the middle, and idle at the front. So let's now add that last change. And the way we're going to do that is we're just going to come in here and say var idle to phase check. We're going to get that previous transition. This is going to be idle.transitions.first or default, similar pattern that we've seen before. And then we're going to say t.toState is equal to phase check.name. So we're getting the transition inside of the array of transitions that has the toState equal to the phase check state, which is the one that we are looking for here. And then all we're going to do now that we have this is we're going to say idle to phase check dot toState is equal to the reposition state dot name, and then finally the idle to phase check dot FSM state is equal to the reposition state. And so now what we've done, if we come back to our paint thing here, is now we've actually wired this correctly. Because if we look at the code here, let me try to get it all on one screen here. So the first thing that we do is we create this new transition. So this transition that we've created is basically this little block right here. And we've set this equal to the, well, not equal to, but we set it to point to the phase check state. So we take this transition that we just created, we point it to phase check, and then on the idle side, we now make it so that idle points to reposition. So now idle points to reposition, reposition points to phase check, and then phase check goes and does whatever it does depending on what phase we're in and everything. So now we have this wired up correctly, we are done. We have our full reposition state set up correctly. So let's just recap it before we test it out. So basically what we have going on here is we're creating this new reposition state by just creating a new FSM state and then appending it to the list of states. Then we're creating a list of actions that we're going to use in our state. So in this case, we are just going to move it to the left side of the map, and then we are going to wait for about half a second. And then finally, we do the transition wiring where we interpose it between idle and phase check to basically give that little dodge between each attack that happens. So we'll build this up and we will test it out and see how it works. Alright, so we're back in it. Now what we're expecting to see from the fourth chorus boss here is between each individual attack, it will shift over to the left side of the screen, and then afterwards it will slide back in for whatever attack it wants to go for. So let's see what happens. We'll start off with a 2.5 second wait, and then it should slide over, and it does, perfect. So what we've done now is we've made it so that the fourth chorus boss has a little bit of defense against being locked into place, right? Because if I try to pogo on it now, then it's just going to jump away from me, and it moves quite quickly, so it's hard to track down. Now, obviously, there is still the exploit. If I stay on this side of the map, then I probably could still get it. Ooh, actually, it's still a little tough, honestly. which is awesome, right? That's what we wanted to do. And we could continue to expand on this, right? Instead of always jumping to the same spot every time, we could, in theory, make it more flexible by making it jump away from the player, or something like this. And so, I think that's a little bit out of the scope for what we're talking about right now. So I think that this is a great stopping point, and this is mission success. All right, so that is going to do it for today's tutorial. I really hope you guys found this, useful and informative. A couple quick little ending notes here. First of all, I just wanted to say thank you. I know you guys had really great reception to the first video that I put out talking about the boss modding, and so I'm really happy that you guys found that helpful. If you guys have any ideas for modding tutorials that you want to see, please post that in the comments. I would love to make more tutorials to help you guys out. And yeah, I mean, this has been a lot of fun so far. I have a boss showcase video coming out tomorrow for the fourth chorus. It is quite a bit more put together than what we're seeing here. So please check out that. If you want to keep tabs on what I'm working on or catch future tutorials that I'll be making, be sure to subscribe. And that's going to do it. So thanks so much, guys, and I'll see you next time.